Behind me is a collection of over 1 million individually labeled rock samples and 50 kilometers of core. The Oil, Gas, Soil Resources Library, located in London, Ontario, is the warehouse for all drill samples from borings drilled in Ontario under the Oil, Gas and Salt Resources Act. These millions of individual samples are related spatially. By placing them in space, geologists can study the rocks for patterns. Maps continue to be an excellent tool for examining the relationships between these data. Digitization of data brought GIS and most recently a 3D model of Ontario's major Paleozoic bedrock formations. To improve geoscience communication and make comprehension of the model and our geology data more intuitive, we've created a number of experiences from the existing 3D model. First, we created some virtual reality videos that are a 3 degrees of freedom experience, and we've created some 6 degrees of freedom experiences that take place inside a virtual geology app. Why don't we go and take a look how that was done. The three-dimensional geological model of the Paleozoic bedrock of Southern Ontario that we will be using was created entirely in a modeling software called Leapfrog. This software uses real-world geological data to model volume. All objects were then processed using Blender, a free and open source modeling software. For a 5-minute video, the total frames required stands at 18,000, and each frame, taking 10 minutes to create, would be about 3,000 hours or 125 days. A cloud computer service with 192 computer cores and a few other tricks were used to render the video in 1 week. Since the completed video appears as a normal square video, it can be played back on any device. Finally, it's time to tour the VR video. We start by flying along the surface. Look at the features of the superficial bedrock. Buried valleys. There are several locations where the Great Lakes would connect if all the overburden were removed from the bedrock. Buried escarpments. Flying west to east, the first escarpment we see is the Onondaga. Of course, the Niagara Escarpment is impossible to miss. Some parts of the model, like near the Precambrian boundary, have a lot of detail due to the high number of points that touch the bedrock. As we explode the model and inspect the top of individual layers, features we don't normally see are exposed. Salt dissolution collapse features, the start of faults, arches, and sags, salt layers of great economic importance due to mining and cavern storage, Guelph Age pinnacle structures that are foundational for Ontario's year-round stable natural gas storage and supply. What is a VR app? A VR app takes the immersive stereoscopic viewing experience and adds another 3 degrees of freedom. For the app, we chose to start with the Unity game engine. We chose a simplified version of our laboratory facility and warehouse. The user can interact with the elements in the lab in a number of ways. They may view the 28 mostly continuous layers from the 3D model, inspect a 3D object representing some of the unique geology from each of the resource types, oil, gas, salt, and water. They may inspect virtual cores, watch several short videos inside the app providing background information on the resource types, and dive right into the layers and walk across them to inspect them up close. As the user walks across each of the 28 formations, they may drop a pin at any location to query that layer for known occurrences of oil, gas, salt, or water near that location from real borehole records. In a way, this is an open-world exploration tool. Thank you for watching this brief presentation from the OGSR library. All of our virtual reality videos will be available on our YouTube channel at youtube.com/c/OGSR library. They can be viewed on any device. Our Geology Lab app can be viewed on a MetaQuest headset, either here in the library or at one of our partner locations. We hope you stop in and check out the Geology Metaverse soon.